Drude theory. Okay, so the electron was discovered in 1900. Okay, and Drude gave this free electron theory in 1903 after 3 years of discovery of electron. Okay, so this theory, what it says, okay, so this theory is able to explain quite a properties of metals, like we can explain DC electrical conductivity of some metals, electrical conductivity. Okay, number two, we can explain Widman-French law. Widman-French law. With this theory, we can also explain Hall effect in metals. Okay, and we'll also going to see that this theory is also able to explain optical reflectivity of metals. Okay, so basically, what is this theory? What are the assumptions of this theory? Okay, so there are two important assumptions. One is independent electron approximation, and other is the free electron approximations. Okay, so what is the meaning of independent electron approximation? Number one, ki your electron in the metal or crystal, it behaves like a sea of electron. Okay, it behaves like a classical gas. Okay, so the assumption first is electrons, okay, electrons behave like classical gas. Okay, classical gas. Okay, and the other important thing is in
classical gas means
classical
like
gas
gas only.
classical gas का
Real
मतलब है
gas.
real gas, real ideal gas. Okay,
Oh, ideal gas.
so classical gas का मतलब क्या है कि इनके बीच के अंदर इलेक्ट्रॉन के बीच में कोई लॉन्ग रेंज फोर्स नहीं है. दैट मींस यू विल नेग्लेक्ट द कूलम्बिक इंटरेक्शन. ओके, जो कूलम्बिक इंटरेक्शन है इलेक्ट्रॉन के बीच में और इलेक्ट्रॉन आयंस के बीच में, दैट वी विल नॉट कंसीडर. ओके, सो फर्स्ट ऑफ थिंग, दिस मॉडल सेज दैट इलेक्ट्रॉन that metal, you can visualize metal as a where the positive ions are fixed. Okay, and electrons are free. Okay, and these electrons are delocalized. Delocalized का मतलब है किसी भी एक इलेक्ट्रॉन के जो इलेक्ट्रॉन है वो अपने एटम के पास में नहीं है. Okay, so this whole electrons are belong to the crystal, so they make sea of electrons. Okay, electrons are like a gas molecules, and between the electron and electron ion there is no Coulombic interaction. Okay, that means there is no long range interaction, there is no long range interaction, okay, between electrons, okay, and electron, and between electron and आयन. ओके, इनके बीच में कोई भी लॉन्ग रेंज इंटरेक्शन नहीं, कूलम्बिक इंटरेक्शन नहीं है. इसको बोलते हैं इंडिपेंडेंट फ्री अप्रोक्सीमेशन. दिस होल स्टेटमेंट इज कॉल्ड इंडिपेंडेंट फ्री अप्रोक्सीमेशन. ओके, एंड रियल कंडीशन में दिस अप्रोक्सीमेशन इज वैलिड. ओके, क्योंकि इलेक्ट्रॉन के बीच में जनरली कोई इंटरेक्शन होता नहीं है किसी भी कंडीशन में. ओके, बहुत स्पेशल कंडीशन. ओके, so this independent free approximation is valid, always valid. Okay, and the second is what? Free electron approximation. Okay, free electron approximation क्या है कि उनके बीच में coulombic interaction तो नहीं है, but they can collide. like जैसे जो सिंपल गैस के एटम कोलाइड करते हैं ना. ओके, तो जैसे गैस के एटम कोलाइड करते हैं, एक दूसरे को एनर्जी एक्सचेंज करते हैं, तो सिमिलर वे इन मेटल आल्सो इलेक्ट्रॉन बिहेव लाइक अ नॉर्मल गैस पार्टिकल. ओके, सो व्हेन दे
टेम्परेचर ओनली,
हां, due to temperature only. So electron can interact means they can collide with electron, they can exchange the temperature, they can collide with the lattice. Okay, so and in between the lattice they are free. Okay, so the second approximation is what? Okay, the positive ions are fixed in the lattice. Positive ions are fixed, are at fixed positions, okay. Electron collide with this, electrons collide with these ions, okay, and get scattered, okay. But important thing is between two collision, okay, electron move in straight line, okay. Between two collision, electron move in a straight line, okay. This is called your free electron approximation, okay. This is called your free electron approximation, okay. And this is not true always, okay, because if you see superconductor, okay, there your electron is not colliding with lattice, okay. If your temperature is low, then also there is probability very less that electron is colliding with your lattice, okay. We'll see that things, okay. So these are the two approximation based on your Drude theories. Drude has derived, okay, some properties of this metals, okay. Now because now electrons are behaving like a classical gas, okay, so obviously it will obey, okay, what kinetic theory of gases, okay. So the third point is electrons obey, okay, kinetic theory of gases, okay. That means if I want to calculate the mean thermal energy of electron, okay, that will be equal to about what, 3/2 kBT, okay.
Yes, sir.
And at room temperature, if I calculate this VT value, it will come around 10⁵ centimeter per second, okay. So that means because of this thermal energy, okay, meter per second per second. So that means because of this thermal energy, electrons in the solids, okay, they are moving with such a high velocities, okay. And what is the probability of scattering, okay. So but I told you between two collision, electron move straight line, okay. So so that distance is called mean free path, okay. The distance between two collision, okay, where electron is free, that is called mean free path, okay. And the electron gets scattered only after relaxation time. The time interval between the two collision is called your relaxation time, okay. So so you can write the time interval between two collisions is tau, okay. And tau is what? Tau is relaxation time.
Sir,
Huh.
ये at RT, VT, RT means what?
Which RT?
Sir,
Room temperature. This
sir,
room
room
temperature.
temperature.
Room temperature, okay. Now, shall I rub this one? Okay.
Yes.
So
Okay, sir.
now if I want to write mean free path, so mean free path will be what equal to? Okay, distance equal to what? Velocity, VT. Okay, VT into tau.
Tau.
Okay. So if I give, suppose lambda equals to 1 nanometer. Okay, if I write lambda equals to 1 nanometer, okay, VT is already what? VT is we have the 10⁵ meter per second. Okay. Okay, so this will give me tau. Tau will be almost 10⁻⁻14 seconds. Okay, this will give you the value of tau. Okay, so these are the 4 important points of Drude theory, based on which we can explain the DC electrical conductivity of.
हेलो सर,
हाँ बोलिए.
एक बार प्लीज रिपीट करेंगे, मेरा बीच में इंटरनेट पूरा चला गया था.
कहाँ से रिपीट करना है?
और ये थर्ड पॉइंट लिखा है ना, उससे मतलब मैंने सिर्फ नाम ही सुना था थ्योरी का, उसके बाद पूरा चला गया.
So I told you the electron behave like a classical gas. Okay, classical gas है तो kinetic theory of gases भी obey करेगा. काइनेटिक थ्योरी ऑफ गैसेस का मतलब है द काइनेटिक एनर्जी ऑफ दिस इलेक्ट्रॉन इज इक्वल टू 3/2 kBT. Okay, and if we solve this equation, okay, this thing, okay, if we calculate the kinetic energy or velocity of atom at room temperature, putting T equal to 300 Kelvin, it will come around 10 to the power 5 meters per second. Okay, this is the thermal velocity of electron. Okay, without the application of any electric field, you have a crystal, the thermal energy, and your electrons are moving. So basically we should not call it the velocity, it's the speed. Okay, speed hai, velocity means it should have some certain direction. Okay, so this is the speed of the electron, because the total velocity is zero, क्योंकि crystal में current तो है नहीं. If you are heating the sample, if your sample is on temperature, okay, so your electron is moving. Okay, that the motion is random, it is colliding with the ions. Okay, and but it do not have any particular direction, it do not have a velocity in particular direction. Okay, that means its average velocity is zero, but speed is very high. Okay, so this point you can understand. Suppose we have a crystal. Okay, we have this lattice.
Sir, so it means at room temperature also electrons are moving with this
Yes.
speed in
Yes.
metal.
They are moving with this speed. Okay, if we are
Okay.
not applying electric field, they are moving with this much high speed. Okay, so this electron, how they are moving? Okay, so they are moving like this. Okay, they are coming here. These electrons are moving, they are colliding with ions. Okay, they are repeatedly colliding. Okay, so they don't have any particular direction. Okay, so their average velocity is zero, but they have a speed, very high speed, because of thermal energy. Electron is very
This
tiny
is
particle. Electron is very tiny.
RMS?
Yes.
This is RMS?
Yes, it should be equal to RMS. Okay. Okay.
Yeah.
So because they are very tiny particles. Okay, and temperature. Okay, because of this temperature, even in room temperature, they have very high speed. Okay. So now what happens when we apply electric field? Okay. Now when we apply electric field, then these electrons, okay, they will move in a certain direction with some speed. That speed is called your drift velocity. Okay. Now if I want to calculate the current, okay, I should know how many free electrons are there, okay, in the metal. So how to calculate the free electron density in the metal? Can anyone tell? How to calculate the number of conduction electron? Okay, the 0.5 of Drude theory is number of conduction electron. So like example, this is sodium hai, copper hai. Okay, so conduction electrons are coming from what? Where? They're coming from atom only, na? Okay,
Yes,
so all the valence electron, okay, the valence electron will be very loose electron. Okay, and when you make metallic bonding between this atom, these valence electron get free. Okay, so if I want to calculate the number of conduction electron n, okay, the number of conduction electron is simply what? Density of atom. Okay, density of atomic density, say m divided by mass number. Okay, so this is atomic density. Atomic density means what? Kg per meter cube. Okay, now if I divide this density, okay, by atomic mass number, I'll get number of atom per meter cube. Okay, this is what? Number of atom per cube. This density kg per meter cube. If I divide by this and the mass of an atom, okay, this will give me number of atom per meter cube. And if I multiply by electron, suppose one electron, that will be free electrons. Say free electrons is ZV. Okay, now ZV can be one. For example, of alkali metals. Okay, like sodium हो गया, even copper से copper, they'll give one electron. So जितने atom है उतने free electron हो जाएंगे, क्योंकि each atom will give one electron. ये point clear है? हाँ.
ZV
सर
means
ए
what?
क्या नहीं होगा, आई थिंक सर मल्टीप्लाई होना चाहिए.
हैं?
वो तो डायमेंशनल. सर ए आई थिंक डिवाइड नहीं होगा सर.
ये मास नंबर है, मास नंबर, एरिया नहीं है.
अच्छा मास नंबर है. ओके ओके सर, मुझे लगा एरिया है.
नहीं मास नंबर, ए इज मास नंबर. ओके, एटॉमिक मास नंबर.
ZV
कांस्टेंट है भी. जैसे कोई अल्कलाई आइटम सोडियम है तो वो एक इलेक्ट्रॉन उसके पास फ्री वो एक इलेक्ट्रॉन दे देगा. जैसे कॉपर है, ओके, इट विल गिव वन इलेक्ट्रॉन इन द सिस्टम. एक एटम से कितने इलेक्ट्रॉन मिल रहे हैं, कितने वैलेंस इलेक्ट्रॉन एक जो एटम है कितने वैलेंस इलेक्ट्रॉन कंट्रीब्यूट कर रहा है सिस्टम को, मेटल्स को. Okay, that is ZV. Okay, for alkali metal is 1, alkali halide it is 2. Okay, I'm not writing it 2 here because that is not always true. Okay, so for example, how many electrons contributed, how many valence electron, okay, how many valence electrons are contributed by atom in the metal. Okay, अगर एक एटम एक इलेक्ट्रॉन दे रहा है तो जितने एटम में उतने इलेक्ट्रॉन देंगे. एक एटम अगर 2 इलेक्ट्रॉन दे रहा है तो जितने एटम है उसके ट्वाइस आपकी कंडक्शन इलेक्ट्रॉन डेंसिटी हो जाएगी. ओके, क्लियर?
Yes, sir.
Okay.
Yes, sir.
So this is your Drude theory. Now with using this Drude theory, I will try to explain some of the properties of metal. Okay, so for example, DC electric resistivity. Okay, so put the heading DC electrical conductivity. Okay, now what is DC electrical conductivity? Okay, so suppose you have this solid. Okay, now you're applying a voltage. Okay, so this voltage will set up an electric field inside this metal. Okay, and because of this is x direction, suppose. So because of this electric field, this charge ions, they will experience force, and they will start moving. Okay, they will accelerate. Okay, so we know that Ohm's law is valid. Okay, if I apply Ohm's law, so Ohm's law is what? Ohm's law is what? Your sigma E equal to J equal to sigma E, J equal to sigma E. Okay, or simply if I write A equals to rho J. Okay, this is your Ohm's law. Okay.
Yes, sir.
So this is macroscopically. I know electric field, I know voltage, I know the length. Okay, if I know voltage, I know length, I can calculate electric field. Conductivity is inversely proportional to rho. Okay, so your resistivity is what? 1 by sigma, and this is what? This is Ra. If I take R is proportional to what? Rho L by A. So if I can measure the resistance experimentally, Ra by L. Okay, I can measure the conductivity. So this is the macroscopic point of view, right? Okay, external parameter है. If I can measure externally resistance, measure कर लूँ, इसका cross section पता है, length पता है, so I can know the resistivity क्या है material का. Okay, if I know what is voltage, what is the length, I can calculate the electric field. So I can calculate the current density using external parameter. Okay, so this is macroscopically. Okay, now I want to relate this macroscopic parameters, okay, with macroscopic parameters like electron concentration. Okay, electron concentration भी हर मेटल के लिए कंडक्टिविटी J अलग क्यों आती है? I'm applying same voltage, everything, but every material will give different resistivities, different conductivity values. So now I want to relate this with the macroscopic parameters. Okay, so microscopic point of view, I want to see this Ohm's law with microscopic, okay, point of view. Microscope मतलब internal properties कैसे related है. Okay, so now when I apply voltage, okay, what will happen in the conductor? Okay, now your electron will acquire a velocity. Earlier when there was only thermal energy, okay, your electron were randomly moving. They're not moving in particular direction, they are just colliding, and their average velocity was 0. But when you apply electric field, okay, now electric field will force electron to move in certain directions. Okay, so even though there is a collisions, okay, so suppose even though there is a collision, but somehow your electron will move in a particular directions. Okay, that means we say it has at least some average velocity. Okay, that velocity is called drift velocity. Okay, so when you apply electric field in the metal, okay, your electron will start moving with a drift velocity. Okay, so suppose this is my electron. Okay, this is my electrons, these are my electrons. Okay, they'll move with a certain velocity. Okay, that is called your drift velocity. Now,
Sir,
huh,
means the velocity after electric field, after the application of electric field is known as drift
डिफ्ट
velocity.
वेलोसिटी, ओके, क्योंकि पहले तो वेलोसिटी था ही नहीं, ओके, अभी एटलीस्ट ये कि हम भी, अगर पहले वेलोसिटी होता तो करंट होता, अब रखे हुए क्रिस्टल में कभी करंट होता है क्या? करंट होता नहीं है, दैट मींस वेलोसिटी है, करंट नहीं है, इसका मतलब वेलोसिटी नहीं है। अभी हम वोल्टेज लगा रहे हैं, करंट मिल रहा है, करंट मिल रहा है, इसका मतलब क्या है? इसके अंदर वेलोसिटी है, इलेक्ट्रॉन के अंदर, इलेक्ट्रॉन्स आर मूविंग इन सम पर्टिकुलर डायरेक्शन, ओके। नाउ,
Yes, sir.
okay, now I want to calculate, I want to relate these parameters, okay. So suppose I want to calculate now current density, okay, J. So J is what? I by A, okay, and I is what? I is your del Q upon del T, okay, del Q. So definition of I is what? Charge moving per unit time, okay, through any surface, okay. Suppose here some distance is delta x, okay, delta x distance is there, say this distance is delta x, okay. So I'm telling now I want to calculate how much charge is passing, okay, per unit surface, okay. So in surface, this is delta x distance, okay, and how much charge is passing through this area. So I know the velocity is vd, okay. So how much charge is present in this delta x region, okay. So I know the cross section area is a, okay, length is delta x, okay. So this is my volume of this small part, and if I know the charge carrier density n, density kitna hai present, okay, so I can know how much charge is present, okay. So how much charge is present, that q can be written as, this is cross section area, q can be written as n a delta x, okay. So if I want to calculate the current, so I can write simply a delta x upon delta t, okay. Now the delta x upon delta t is what? Your velocity, and this is a number density, and the charge is E, okay, minus E, electron charge is minus E, so I have to multiply this by minus E, okay. So this become minus Ne, okay, a delta x upon delta t become your velocity Vd, okay. So this is the expression for current. ये expression clear है? I want to understand.
तो माइनस ई से क्यों मल्टीप्लाई किया?
माइनस इलेक्ट्रॉन का चार्ज है ना, भैया कुछ चाहिए
Okay.
चार्ज, कितना चार्ज मूव कर रहा है. This thing
Okay,
I have already explained in semiconductor also, na. We have derived this relation there also. So how much current means how much charge is passing per unit second, per unit time. तो per unit time का मतलब है per second में it will cover Vd distance. It will cover Vd distance, okay. And Vd distance cover करेगा, इसका मतलब Vd एरिया के अंदर लाइन लेंथ जितना भी चार्ज है वो सारा यहाँ से पास हो जाएगा. और Vd एरिया के अंदर कितना चार्ज है? Vd distance A is the area and this is the charge, okay. So this is total charge. This will pass per second through a area, okay. So this is the definition of your current, okay. Now if you want to calculate J, ये पॉइंट क्लियर है ना? डेरिवेशन
सर वो माइनस हमने इलेक्ट्रॉन के चार्ज के लिए लिया था.
हाँ, माइनस इलेक्ट्रॉन चार्ज के लिए लिया हमने, okay. So now if I want J, okay, so J will be what? J will be I by A, okay. So simply this current will be minus Ne Vd, okay. This is the expression for current, minus Ne Vd, okay. To say this is equation number 1. Ohm's law you can give equation number 1. This is 2, okay. Now I'm applying what? Now I need to calculate this Vd. What is Vd? If you want to calculate current, I know this carrier density, theoretically charge I know. I want to calculate this drift velocity, okay. So for drift velocity, what I can do, when I suppose I have a charge, I have a ith electron, okay. So I can write Newton's law, dv by dt, okay. It will be equal to what? What is the force? Electric force, okay. This is E, okay. So if you can write Ex, if in one dimension, okay, you can, if you understood, then you can simply write E, okay, which is in x direction, okay. Now I want to calculate Vi, okay. So assume, okay, that now one more assumption is there. Any question? So one assumption is there that when electron collide with when ion, okay, so after that its velocity is random, okay. You don't know whether it will move in x direction or minus x direction. The after just before the collision and just after the collision, okay, we don't know the velocity of electron. Okay, so what will happen? I assume that the initial velocity is at t is equal to ti, say it is ui. Okay, v equal to ui. Okay, now solve this equation. This equation will give you the velocity of ith electron. Okay, solve this equation. What will give? इसको मिटा दूं मैं?
Yes, sir.
Yes, sir.
Now, if you solve this equation, what will it give? It will give you v, okay, as a function of time. It will give you what e upon m t, say some constant. Okay. Now, if you apply initial condition, okay, t equal to ti, so minus e m ti, okay, and then you will get the velocity, say ui. Okay, I'm assuming ui. You can assume 0 also. Okay, so ui. Okay, so if it is ui, okay, so this will give me what c1. C1 it will give me ui plus ei ti upon m. Okay, so I can write the velocity of vi. Okay, ith atom I can write minus ee upon m. Okay, plus ui plus ti upon m. Okay, and this I can write
Sir, T means हो गया ना?
yeah, just 1 minute. E upon m. Okay, and so t is there. Okay, t minus ti. Okay, हाँ, अब बोलिए.
नहीं अब ठीक है sir.
हाँ, so this is the your velocity of your ith atom. Okay, now I know that electron only get accelerated for what time? It get accelerated only for relaxation time. Okay, some electron have a scattering time less than scattering relaxation time. Some electron have a scattering time more than relaxation time. Okay, but on average, okay, they have only relaxation time where they get in which period they are freely accelerated. Okay, so now I can write ui e m. I can write this as a tau. Okay, so this is the velocity of ith atom. Okay, ith electron. Now I want to calculate drift velocity. So drift velocity is simply average of all the velocity of electrons. Okay, so if I want to calculate drift velocities, okay, that is simply okay equal to 1 upon n. Okay, say I told you vi, you know, or you can write v1 also. Okay, so so say vi v1. Okay, vi with I means 1 2 3 4 5. So say this is v1 v2 plus v3 and up to how much? And we have n electrons, so I can go up to vn. Okay, vn. And if I write now 1 by n, okay, if I put the value of v1 v2 v3, okay, so what will happen? This ui, okay, sum of ui will become 0. Sum of all the ui will become 0 because it is random. Okay, just before the collision. हाँ.
सर ये लास्ट 2 पॉइंट जो बताए एक बार फिर से.
So now our aim is to calculate what is the drift velocity. So drift velocity is the average of velocity of all the electrons. Okay, so now if I sum this all the things, okay, I'll get n ui. Okay, n ui minus n e, okay, m upon tau. Okay, now I am assuming this ui, okay, n ui average of this initial velocity before it gets start accelerating. Okay, this is random. Okay, so this will average out to average. The average of this one will be 0. Okay, so ui averages sum of ui averages to 0. Okay, so we'll get drift velocity only equal to what? Minus e upon m tau.